appreciate that. Today I have a presentation about interesting subject. That's mean how can you design the project. Before, as you know, my name is Sami. I'm doing the master in mathematics, and this presentation related to mathematics and statistics. Thank you once again for that. We heard about how can you use statistics to make project. Project is wide subject. You can use any type of statistic. The famous software Minitab, MATLAB, and R-Square, but the easiest software is called Minitab, and the QT provided this for free for students. Let me start with the definition for statistics. As we say, is the study of natural variation. That means random chance, that you can't expect this matter will happen or not, just maybe happened by chance, like when you flip the coin and you don't know, you have 50% have a head or 50% tail. The other definition or formal definition, this is like, as we say, the statistic is used to observe data and models of chance, like probability theory, and to understand and interpret and predict patterns in variable outcomes. I will give the example for that. Like if I'm interested in if the patients in emergency department, if they're waiting for patients, if that match up with the recommended waiting time for government when they set up the recommended, because we know in the most of countries in the world, they set up the recommendation or recommended waiting time. That we have, they divided the categories of patients to 5. First one, when they can't wait, they have to treat immediately. And the second one, category, this is called the category 2, they maybe can wait between 0 minutes until up to 10 minutes, because they doesn't have the high risk as the previous or the category 1. And the third, fourth, fifth one. The fifth one of category that can treat it by nurse, because it just has minor risk or condition that can treat it by nurse. Okay, this is the definition of statistics, that if I collect this data, that may be number of patients and age, and we will say this in the end of the project or the presentation, how can we design the project, and we will see how can collect the data. Today, just I will focus for how can you collect data, what's the matter of the data or issues for the data when you collect it, because it's not easy just drop the hospital and collect the number of hospital or get it from resources. You have to understand what data you should collect it, and before that you have to set up the questions, what I'm interested for, to answer or to make the project. Okay. Okay, the two questions to make simple the project for yourself. You have to ask yourself how and why for this question. Like when I did the recommended waiting time for emergency department, I asked myself if the real waiting time in hospital, real hospital in Brisbane or in anywhere hospital at emergency department, if that match up with the recommended waiting time that the government set it up or no. If you take the data, real data, and make analysis data for this data, and you will find the answer of a question, the end of project. You will find if is that match or no. If no, you have to ask why. Where is the problem for that? Just to predict what will happen in emergency department, for example. Okay, as we say, this to achieve this statistic or this project, to achieve or to complete my project, I have to make 3 stages. The first one will be like data gathering or collecting. Okay, the first one, data gathering, that you can get the data from resources, formal resources. You can take it by yourself, go to hospital or shopping, what you are interested, and collect the data. This is called observation data. You can collect it online, and you can collect it by survey data. That you have many types of data. You can collect the data. The second one will be data summarization. This is related to statistics. If I get the data and collect the data, and now what the next step? Next step, how can you summarize the data? How can I interpret the data? How can that statistic help me to interpret the data, like graphs, like to read the data? Because the data that I collected, just number or qualitative. By the way, data, we have data. How many data do you think we have? Questions? Yeah, 2. Yes. Okay, can you tell me?
Continuous and discrete.
Discrete, yes. We have 2 types of data, discrete and continuous. What's the difference between them?
Discrete is like this, you can count 1, 2. Continuous is like high and weight.
Yes, right. To make it easy for you, you have discrete and continuous. And this is this help information for someone interested to make a project in future. Discrete, that's fixed number, like natural number. No, that's a number like 1, 2, 3, 4, like person, 1 person, 2 person. You can't say 1 person and half. This discrete. For continuous, no. You can get value between 2 numbers, natural number. That may be 1.5, 1.3, 1.6. This is continuous. Also, the data, we have qualitative and quantitative. Many times we heard this qualitative and quantitative. Anyone has idea what's the difference between them, qualitative and quantitative?
Quantitative has to do with, I think, how can I put it? It has to do with like quantifying your samples. While qualitative has to do with checking the integrity of that data.
Yes, yeah. You're right, yeah. To make it easy and simple definition for that, quantitative, this quantity, that's numbers, related to number, quantity, and it's easy, and the famous data, and the researchers or students, they focus for that. Qualitative, this related to description, color, gender, male, female, describe something, no numbers. That's difference between them. Okay, the last thing is data basic estimation and inference. This is deep in statistics. This is related to variance and standard deviation, because this you have, when you make the project and start to analyze the data, you have the numbers that you have, the data, you will interpret it to graphs, like histogram, by chart, we will see later. This, how can you read this? This is, you have to focus for mean, that's average, and standard deviation, because if you can read the graphs, you can understand your data. Okay. Any question so far? It's clear?
Yeah.
Okay. Okay, I think now games. Okay. We will play now. One can volunteer. One can volunteer. Who can help me? You? Okay. Okay, that's simple thing. But I think you have to jump on table. No. Come here. Come here. It's okay. Just to say the random, you know. Now suppose you have two paired coins, like this, and which you flip, yes, repeatedly and behave as follows. As now, like constructions, just let me. Yes, take the same size. Okay. Now, if we flip it and find HH, we will step right.
Okay.
Okay. HT, left. TH, right. And TT, sit back. Okay. But, yeah. Okay, we will play 6 times for that, okay? Okay. We will, now, we will see what? Yeah, HH. Step right. Yes. Now, the second one, I will do it here, so it's easy for me. This will be the first one. This TH.
TH forward.
Okay. Now I will read it again. This TT.
TT is what? Back.
Yeah, one. This third times, huh? This HT.
HT forward again.
Left, yeah. Yes, you're right. And TT.
TT
6.
back.
Yes, 6 times. Okay, thank you. I will just, I will stand here. Okay, thank you so much. Okay, now he starts from here, I think, okay?
Yeah.
Yes. And randomly, we played or flip the coin. They start step right, right, left, forward, back. Okay, but you are lucky, didn't go out. Yeah. This is random because you don't know, you have 50%, but here not 50%, you have 25% probability because you divide it by 4, that you have equality 25% probability or chance to do the best. If we do this 10 times, 20 times, maybe he will go out, but we don't know from the door or window. Yeah, this is chance. This is about data. We will collect the data, but we don't know what's the result. We will use the graphs, we will use the statistics, like softwares, and we will get the answer. We didn't know for sure. We didn't know if the answer that we needed or that we wanted or no. Okay. Okay, as we said for Harvey. Okay, as we say, just this remind you, we have quantitative and qualitative the data. All of that, that's for how can you analyze the data. Because, okay, we will give the data. How can I analyze the data? How can I interpret the data? How can I read the data to answer my question? Okay, for example, yes, Because we are interested in average and standard deviation, that's mean and variance, that proportion sometimes and or average. This example, the last unit I taught had 160 students, that 100 undergraduate, 50 master graduate, and 10 PhD. One day I asked them, do you think you will like this unit? Because if you want to set the question, you have to be set it as a statistic. Like, if I do it now, I'm interested to ask why female go shopping side or something like that more than me. Okay, this is a question. But that I can't make my project like a question, because this social question, why female more than? But if I want to ask, I will ask, is the female or is female go to the shopping more than male? Yes, that statistic question. I have to go to like some side and observe the people or population and get the sample size and analyze the data, because you have to ask the statistic question, not like social question. Okay, now I ask it, we have, yes, this numbers, when they said yes, we like this unit, the number no, and people who he didn't know, he hasn't any opinion. So the question said, overall proportion saying yes. Okay, this is little bit mathematics. Okay, how can I answer this? I want the percent for a student who said yes. So I take this number, 20, 15, 5. If I want percent, just because he said yes, and divide it by all the number, or the total number of students. So I said 20, 50 that 35, 50 that will be 40. 40 divided by 160, because all the number of students will be 160. And get the answer. This is the proportion of students who said yes. If they ask it, as we said, if we ask it among with an opinion, the people who said yes, but they have opinion, I will take the total number of students who said yes, but this time, should I divide it by the total number or no?
No.
What's the number we should divide it by? No.
I think you should divide it by the total combination of the numbers that said yes in that for that answer.
Yeah. Take this number and divide it by the total number of who said yes?
Yes.
Okay, any answer? You are near, but not correct. Okay, just this here with an opinion. That's mean who has an opinion? Yes, you will delete it because you are not interested. Okay, because the data, when you collect the data, sometimes you just are interested in something, you know, not all the data. When I collect the data, like the last time I collected from emergency department, I just interested for number of categories and the waiting time. I have age, I have waiting time for doctor, I have the waiting time for doctor who wait the nurse, the number of doctors, but I'm not interested for that. I just interested for two things. So the question said, who said yes? I will take this first row and divide it by the total number of yes and no only, not for don't, because they hasn't opinion. Okay. Clear this? Okay, I know the mathematics is boring. Okay. Data is composite because we data, sometimes we collect a lot of data, huge data, and we want to compose the data to take the right data. Okay, the data I have, because I will just make it easy for you, I have variables and subject or units. But in other words, variables, this related columns, and subject, this related rows.
So,
That if I collect maybe I'm interested now, the student, the number of students in this room or 6-4 room in this time. Okay, I will collect the number of students. We are 6 or 7 people. We are subject. This is we are subject because the number of students. The variables, I'm just interested the arrival time. You know, this is for me. I arrived maybe 2:30. For Hassan arrived to 35. For Abdelmalik arrived 4.
last person.
Okay. Okay. This is the arrive time. This is variable that I'm interested to study, and the number of students. This is subject. Okay. Okay, as we said, mentioned it as Fahmi said, we have discrete, the data, and continuous. Okay, this is the famous data we have. So, I will make it easy to understand it. We have discrete here, nominal or categorical, ordinal counts. Okay, nominal, this related to name, like the name of the famous city in the Europe, London, Paris, blah, blah, blah. This is name, like gender, female, male. This is, we have discrete because we know now the difference between discrete and continuous. Discrete, fixed number. We don't have proportion. But continuous, no. We have proportion. We have like 1.3, 1.6, 2 point number. So the continuous, this like high, weight, like speed. Okay, I will, the discrete divided into nominal, ordinal count. Nominal, this related to name. Like if I said, we have a Central Valley, we have North Brisbane, we have South Brisbane, this is nominal data. Ordinal, this is order. Something, the order is important for that. Count, like when I pick the balls from box, this is count, the balls, this is count. Continuous, we have interval like temperature, and we have ratio scale. This is actually the most data that's continuous in this type, ratio scale, like height, weight. Okay. Now we said in the row, when in the columns, we said variables. Variables, it's called, if I have just interested in one variable, in one row, just for one row, this is called univariate. Like, I'm interested in waiting time for patient in emergency department. I don't care about age or gender, or I just interested, this is univariate. But if I am interested in waiting time and gender, this is called bivariate because we have two variables. And if I more, they will be multivariate. Just to be easy for you. Buried data, if I have maybe 3 lands, A, B, C, 3 lands. And every land can get outcome from this land in spring and in winter, or in summer and winter. Okay, the same land, but I have different outcomes. The land is the same, but I have two different outcomes. This is called buried data, and it's famous in the data. Okay. Too much information, but we will be fast for this. Bivariate, because univariate, okay, we know univariate, that's one variable, like waiting time, just. Bivariate, no, I have like two continuous. Two continuous, how can I, or what's the best method to solve two continuous? Like if I'm interested in the height of a student and weight of a student, I have two variables. Because they are two continuous, I have to use a simple linear regression. If I have two continuous. Linear regression, yeah.
So what if, for example, you are testing a speed of two fast cars? Is that going to come under
Fast? What are you interested in? Speed, yes.
Yeah.
Speed. You have to ask yourself: speed is continuous or discrete?
It's continuous.
Continuous. Okay.
So
Continuous. You want to just continuous. Okay. How many variables you want? Just speed?
Yeah, just speed.
Okay.
But two samples. Let's say this is a Mercedes-Benz.
Yes.
And this is Audi.
Yes, you have two continuous now.
Yeah.
Okay, because like sample 1, sample A, sample 2, or B. Now you have two continuous. That related to simple linear regression.
Okay.
Why this linear regression or simple regression? That you test the relationship between them. Is there any relationship between two variables or no? Is this famous in the project? How can you design the project? Because if I have two continuous, that means is there any relationship between them or no? Okay, we will talk later about that. One continuous, one discrete, like when I'm interested in speed of car, okay? This continuous. And also I'm interested in the type of car, like small car, middle car, or a big car. Okay, this is the name. This is related to discrete, not continuous. So I have one continuous, one discrete. The famous method to solve it, ANOVA. This is called analysis of variance. You have to test the variance. The last thing, two discrete, and we will take example for this. We will solve it. Two discrete, like I'm interested in the name of car and is big or small, and is the car is foreign or domestic car. Okay, these two discrete. This is used cross tabulation. Okay, multivariate, as we say, multivariate we have more than, and is this more complicated? Multivariate, but most of the students, they did master, they use univariate and bivariate. Multivariate is more complicated. Yeah. Okay. Now, test exam. Okay, quick question. They ask us or give us scenario. We have 23 quicks where you can't read it from here. Okay. One monitored the state of California, the USA. For each, the magnitude, we know the magnitude, what's that mean? Okay, in Richter scale units. That means we are interested in magnitude and the region. We have north, central, and south, where the epicenter was located were recorded. Okay, that to understand from question, because it's hard, this needs someone do this many times to understand the question. If you find the question interest for something, for variables that you have to interested in, you know what the question asked for. He told me that recorded. I have here the state of California. They interested magnitude. They interested region. Okay. And for for each quick a number of monitoring station measuring background acceleration. We have now acceleration and we have distance. Okay, how many variables we
I
have?
think about 4.
4. Yeah. Why? The first one?
Magnitude.
Yes. And what type of magnitude? Is discrete or continuous?
Magnitude will be
Magnitude.
will be continuous.
Discrete, continuous.
I think it's continuous.
Yeah.
Why
Because it might contain, point numbers.
Yeah.
Yeah.
Point continuous and discrete. Discrete, that means I have like one person, 2 person. I can't say one person and half. This discrete. Continuous, continuous, I say like magnitude, yes, I have point like 1.3, 1.6, 1.7. So magnitude, this is the magnitude could be 1.6, 1.10, 1. So this is continuous. The second one,
Come on. Location.
yes, region
Yeah.
or location. We have north and central and south. This is discrete or continuous?
Discrete.
Discrete. And the third one?
Where the everything. Wherever it is. So
Acceleration.
Yeah,
everything.
acceleration,
Continuous.
continuous. Acceleration, you know acceleration, I can't translate it. Acceleration التسارع. Acceleration, and could be 10.7, but 10.8 acceleration. So this is related to physics.
Likewise, distance.
And the last one, yes, like distance. We know the distance could be 10 kilometers, 0.7 or 6. Okay. Now we understand this is the question, and we can answer this question if you have to understand every variables. What's the relative? Because if I'm, we will see later. If I'm interested now just for magnitude and region, magnitude continuous and region discrete. Okay, and I'm interested in 2 variables. Okay, what should I use? I'm interested in 1 continuous, 1 discrete, 1 magnitude or magnitude or and region. So I can't use simple regression.
No.
Yes, and I can't use cross tabulation to answer my question. I have to use ANOVA or analysis of variance. So it's most important to understand that. Okay, we answer this question. The first one, what's the sample size?
23.
Huh?
23?
Yeah, 23. The number of size. How? Because I can't. Like if I'm interested in maybe number of people who said yes, we need the, or Aussie people who said yes, we need our country be republic. Okay, I can't take all the number of Aussie. Okay, I have to take sample size, like 500, 5,000, and usually if I collect much data and a lot of data, that will be perfect thing you have to do it. Okay. Okay. Now little bit deep. Now the data, it's not easy. Just collect the data and just collect the data and interpret it in the software and get the answer. Not easy. You have to understand your data. What's the famous problem or risk in the data? The first one, as we said, we have subject and variables. This is our subject. The problem in the data when I collect the data, representative and accuracy. Representative, this is bias.
Bias.
Yes. Bias, as we said, this is not dirty word. Yes, not dirty word. Bias, that means if I said, okay, I'm interested now to see if the Aussie people like to be their country republic or not. Okay, I will give you the scenario and I will ask you, is there any issue or no? Now, I'm interested for this problem or this matter. I will take sample size from Aussie people, their opinion. Ask them if they like their country be republic or not. Okay, and I just take data from Brisbane and Gold Coast.
That is so bad. Yeah, because Gold Coast and Brisbane, it's not the only part of Australia.
Because this is from the same state.
Yeah.
It's different states.
Exactly.
Yes, you're right. Because this, as he said, this worst bias. Why? Because Brisbane and Gold Coast not represent all the population of Australia. I have to do, that's not mean I have to ask everyone in Australia, but I have to ask in every city,
yes,
in everywhere in the city. I have to sample size for that. Because if I take just for Gold Coast and Brisbane, this yellow balls, they will be like here in this side, you know, that will not represent all of this circle. It will represent here, just here. So that's not right. And you will get a wrong answer if you do that. Okay. The second one, accuracy. Accuracy, that's if the yellow balls, this center, put it in the center. But the most important for data, the bias. You have to make sure when you collect the data. Okay. Okay, we have just like other issue, confounding and interpretation. I will give example for that confounding. Okay, confounding like if I have medicine, okay, this drug medicine, and this I want this medicine, I would let people or patient try or try this medicine. Okay.
Okay, you mean clinical trial?
Yes, this medicine, but I will give the patient this medicine, but I will give only older people, okay, as sample size. And the second try, I will give him the young people, okay. Now, the confounding problem, that means I have gender or age. This age, indirect affect, but they will be affect on the outcome, the result, because we know the young people can trade fast than older people. Yes, and this you have to consider about it when you collect the data, not just concern for like older people. You just give him the medicine or try the new medicine for them just for older people. You have to make mix. Okay, boiling point data. This like I will give you a fast example. The time.
I think you're like 2 minutes.
Ah,
2
okay.
minutes 40.
Really?
Yeah.
Okay, cool. The boiling point, like when I make experiment, I will boil the water. Okay, this water I will boil it here, and my friend family will make the same experiment, but not in Brisbane, in like Melbourne. Okay, is there any problem between this experiment, like bias or issue?
No.
I have to concern about it. I have to make sure with the family for it. Okay, this is a little bit complicated. Yes, like a bit, yeah, different.
The height,
The weather.
the weather, whether sea level.
Yes, and the temperature. That's when I make this. I have to make sure for temperature and sometimes I can't control the weather
Yes.
and pressure. So this will affect my result. Even we collect the same data, but maybe could be my result different about him result. Yes. Okay, we will we will make this. Yeah. Okay, we have what here? The data summarization. Then, okay, I collect the data. I understand the data, and I want to interpret the data. The data, we have pie chart. Like when we say that pie chart, I can, like the earthquake, I can use northern, southern, or central valley. This is the percent of every state. And I can use also bar chart. This is for many time. And I can use histogram, as you say in the board. And this is called whiskers. Just I will show you the graphs. I will not talk about it, no time. Okay, this is the relationship when we talk about it. This, if I'm interested for, as he asked about the speed, car A and car B. Is there any relationship? If there any relationship, I will get this line. This my data point, and looks like line, straight line. This is, I can say there is relationship. But if I find the data point randomly skirted, like in every way, this is, I can say no relationship between two variables. Okay. As I just had this summarize what we said for that. The last thing, median and mean. Okay, median, that's 1, 2, 3, 4, 5. Okay, I can say the median is Fahmi because he centered between two students. It's median. The mean, no, I have to make summation, the data, and divide it by the number. So if I get the mean and median is the same, this is called symmetric data. If I get mean greater than median, they will be positive squared, and opposite they will be negative squared, and this will be in minitab. Okay, this I said this this line we should the data point. If I say this relationship or no, the data point, this dots, they must follow the straight line, the red line. If there any relationship. If not, that means no relationship between them. Okay, the yellow one, that means something happened when I collected the data, and I have to concern about that and fix it. Okay, the last thing, this is, we talk about ANOVA. This is ANOVA. This is the table of ANOVA. And just to conclude what I said, you have to, before you do your project, you have to ask the question. I'm doing my project in emergency department. I have to ask if the waiting time, real waiting time, this related to recommended waiting time or no. And I answered. I will show you the last thing, just for what I did for my project. As you say, this I did this project. This is easy, just introduction and make the interpret this histogram to answer my question. I get this from Minitab and make this to say the spread or sheet for data, and use is there any relationship, as you say, the red line, is there any relationship between two variables? That's all what I want to say today. Thank you so much for coming, and I appreciate that. Any questions?